Hi, Salam Alaikum, and good evening. My name is Omar Ahmed. Today we are going to present our PPL project, which is about smart automation water dispenser. We are group uh, 11. This PPL and microprocessor subject. Our lecturer is Dr. Muhammad Rozaini. First, let's introduce myself and my group members. My name is Omar Ahmed Muhammad, and my group members Muhammad Daniel, Muhammad Badrul, Muhammad Izwan, Muhammad Agil. Let's get started. Basically, we need to have some information for our project before we start. Let's talk about the benefit of water dispenser. We have four factors to be focused on. First one, easy to use. Secondly, safety for children. And thirdly, easy maintenance. Lastly, cost effectiveness. Then let's move for our introduction for this project. Nowadays, water wastage is one of the main problems that occurred in daily life. There are a few initiatives to reduce problems. One of the main problems that caused the water wastage is because of the water leakage or excessive water used. Every house has at least one water dispenser that could be operated manually. There are also some factories that mean on producing water product by using cans and bottles. There are a few of the factories that use automation water dispenser for production. This is because automation water dispenser are more efficient than present water dispenser. So the purpose of using this project named Smart Automation Water Dispenser by using ED68 to build and design that can utilize three states with water for user, either hot, cold, or ice. I'm also going to talk about our objective for this project. We have three objectives. One, to study and explore the IDE 68K software, to design the automation water dispenser using 68 simpler, to upgrade the dispenser system by reducing contact when refill the water. That's all for me. Now let's move it to my friend to continue. Thank you so much.
So here's the problem statement. First, we have a water dispenser. It's a machine that heats up or cools and dispenses water with a refrigeration unit. Second, it is one of the things that most people use with touching the button to refill the water. Third, as we know, many illnesses spread through contact transmission. Last, it is necessary to upgrade the system by using a contactless button, which is called sensor, so that the bacterial infection can be reduced. The most vital resources on Earth is water, which all the living things need to survive. People nowadays, especially the younger generation, are interested in flavored drinks, which is one of the type of water in the age of globalization. However, it takes human resources to make beverages with hot or cold beverage. A push button and sensor are part of the automatic system that operates the hot and cold water dispenser. In addition, how do we write code using 68K microprocessor IDE software? Finding an automated drink dispenser that can save time and reduce the need for staff is the challenge at hand. The motor's running time is the next issue. How many restrictions have been placed on the motor? Every country has a majority of busy workers, so it is necessary to set a suitable time for all users who are busy. The seventh issue is the requirement for a drink dispenser to have a 7 segment. When the user fills the cup with the liquid, the 7 segment will show the information.
So, hello everyone. My name is Muhammad Izwan bin Abbas. So, I will present about the FILA level. What is FILA? It is a fact, idea, learning issue, and the action plan. So, firstly, for the FILA level, we have to save time and reduce the cost to make the automated system by using microprocessor. For this idea, we have used the software IDE 68K simulator for the simulation. For the learning issue, we need to ask how to use the IDE 68K simulator, and for the action plan, we have to conduct a discussion with team members, and we have to refer the notes and software manual of IDE 68K. Secondly, the fact is an automated system that operating when the start button was pushed. For the idea, the system detects the push button to start the operation. For the learning issue, which of the push buttons should be clicked to start the operation, and for the action plan, we have to design and execute the code for push button operation for the hot, ice, and cold water machine. Lastly, for the fill up table, we have the motor start to run to fill in the cup of the water. For the idea, the sensor detects then make the motor to start run. The issue is what will display on several segment of the IDE 68K simulator to display information. For the action plan, we have to design and execute the code for the selection motor. Okay, so for the flow chart, firstly, when the water dispenser is on, so the sensor will detect the water's mode, whether the user wants hot water, cool water, or ice water. So the user must determine their choice by choosing either hot water, cool water, or ice water. So if the user chooses hot water, so LED will on, and the water mode displayed on server segment is hot water, and after a few moments, the sensor detects to stop, and when the user removes their cup of water away from the water dispenser, and the process will stop, and the LED will off, so the stop mode displayed on server segment, and it will end the process. But if the user wants to choose the other choices of the type of water, if the water is cool, so the LED will on, and the water mode display on server segment is cool water, and the rest of the process will same just like the hot water. And for the ice water, the user will determine its choices. If ice water, so the LED for the ice water will on, and the water mode display on server segment is ice water. Then the process will repeat just like the others. So that's all for me. I will send it to Daniel for the coding. Thank you.
Okay, now I want to show the coding and the simulation for our project. Okay, first we start from declaration part input output. Okay, the switch we declare as the sensor to the memory sign P00012. For LED, we declare as the indicator for water mode to the memory sign P00010. And last, we declare for 7 segment display to the memory start from $E0000 until $E0000, which is from segment 1 until segment 8. Okay, now we look to assign initial condition. Okay, now we start the program at the memory origin $1000, and then we use command move.b hashtag $1B1 for first switch, move.b hashtag $2B2 for second switch, and move.b hashtag $4B3 for third switch. Okay, now we move to the main loop and decision part. Okay, for this part we have three type of water mode, which is hot, cool, and ice. Okay, we take one example. Okay, now we use the command move.b So this 3 hexa value move immediate into segment 1, segment 2, segment 8. Move.d hashtag 0 into LED. Compare.d switch D1 EEQ hot. So now if D1 high, so now D1 is high. So go to hot subroutine. Okay, for hot subroutine, we use command move.d, and then for this all hexa value, move immediate into segment 3 until segment 7 to display hot in 7 segment. DSR on for LED on. In switch high, BEQ stop, BARA main. So if switch low, go to stop subroutine. Okay, this for stop subroutine. Okay, for stop subroutine, we use command move.d, and then for this all hexa value, move immediate into segment 3 until segment 7 to display stop in 7 segment. And at the same time, in switch height, LED will on. So we use command move.d hashtag 1 into LED. DSR delay, BRA main. Okay, and the last we have delay. So we use command move.l hashtag $100. So this for subroutine for LED delay. And DNE delay RTS. So RTS stands for return from the subroutine. Okay, for cool and ice is same as flow in hot subroutine, but only different in the value of hexa number to display in 7 segment. Okay, now I want to show the simulation for our project. Okay, first we have 3 sensors, which is the first sensor is from 0, the second sensor is from 1, and third sensor is from 2. So for 0, it will be hot water. For 1, it will be cool water, and for 2, it will be ice water. Okay, now we try to hot water. Okay, now if our cup is close to hot water sensor, the sensor will detect, and this switch become hot. Okay, now we can see the LED will on, and the words hot will appear in the 7 segment display, and then the water will automatically come out according to how much water we want to use. And then if our cup is far from the hot water sensor, the hot water sensor will detect. So this is becoming, and then we can see the LED will off, and then the words stop will appear in 7 segment display. So the water will stop automatically. Okay, now we try to cool water. So same as in hot water, if our cup close to cool water sensor, this switch become hot. So now we can see the LED on in cool water, and the words cool will appear in 7 segment display. And if we want to stop the water, just move the cup away from the sensor, and the switch become low, and the LED will off, and then the words stop will appear in 7 segment display. And last, for ice is same as the hot water and cool water. So that's all from me. Thank you.
And for the conclusion and recommendation, our project has completed this project using Easy68K assembler. As we know, we live in pandemic, so we need to avoid physical contact. So our project has put the sensor that can help user avoid physical contact when we were using this app. So how to use our project? So first, we need to put the bottle at the nozzle. Sensor will detect the presence of object. Second, LED will blink every second. Third, cool will be displayed on 7-segment display. 4. Water will flow out until sensor detect no object or presence. Thank you, that's all from us.